This is an outline for a solution to problem 6.1.25. It is similar to exercise 13 in homework 1. This is a problem dealing with discrete probability distributions. What do we mean by discrete probability? Let's take a look at this chart. This counts the number of live births by a mother. Of course, there cannot be negative numbers here. It's not possible to have -3 live births. It starts off with 1. You cannot have 0 live births because this one is a child. So this is the number of mothers for which this is their first live birth, the second live birth, the third live birth, etc. I'm assuming 8 means 8 and above. This is discrete. We can list the possibilities, 1, 2, 3, 4, 5, etc. These probabilities, 23.3% of the women, this is their first child. For 27.4% of the women, this is their second child. We usually write probabilities as decimals and not as percents. So this goes all the way to, for 5.1% of the women, this is their 8th or higher live birth. This is a probability distribution. If we add up all of these decimals, we should get 1 or 100%. Sometimes it's not quite 1 due to rounding. It might be 0.999, it might be 1.001. It might be a little bit off because of rounding. Let me go to some scratch paper to put this in a different way. I'll resize this a little so that we can see the original chart. So this original chart says that 23.3% of the women, for that many of them, this is their first live birth. That's just like saying 23.3% of people prefer blue. It's like 27.4% of the people prefer green. These are discrete categories. In this case, they are the number of live births, but they could also be colors: blue, green, white, etc. So the first problem, what is the probability that a randomly selected mother has had her 4th live birth? So if you think of this maybe as the color black, 11.1%, or as a decimal 0.111, that's the number in this category. 0.111. For 11.1% of the women, this is their 4th baby. Check our answer. Fantastic. Let's go to the next part. What is the probability of a woman having her fourth or fifth? If we were to continue thinking about colors, that's like saying, what's the probability of being green or white? Here we have two different categories. The probability of being green or white is just we add them together. We add up the two probabilities. In this case, fourth or fifth, let's add up the two numbers. Fourth is 0.111. Fourth is 0.111. Fifth is 0.098. We add them together. That's 9, that's 10, carry the 1. 0.209. For 20.9% of the women, this is her fourth or fifth live birth. 20.9. 0.209 as a decimal. Check our answer. Good job again. Let's keep going. The probability has her sixth or more. 6 or more means 6, 7, 8, etc. So what we need to do is to add those all up. Six, 7, 8, etc. 6 is 029. That's the sixth live birth. Seventh is 037. And eighth and higher is 051. So sixth or more is 6, 7, and 8. I'm assuming that 8 really means 8 and above. 10, 17, 10 and 1, 1. How I added these two is I noticed that 9 and 1 are 10, so 10 and 7 are 17. You can add these in any way, any order you want. So the chance is 0.117. Let's type in 0.117. Check our answer. Excellent again. One last part remaining. How many live births would you expect the mother to have had? Expect means expected value or the mean. In other words, the mean or average value of this distribution. This is not as easy to calculate. Let's do it here. (23.3%). This is their first. 27.4%. This is their second. 16.7%. This is their third, etc. So what's the average value? We have to take the probability times the value. The probability times the value. For the first one, that's easy. The probability is 0.233. The value or the number of children is 1. The second one, the probability is 274. the value is 2. 2 kids. When we multiply that out, that's 548. Third one is 167 as the probability times 3. This one's a little bit harder to do in my head. 21, carry the 2, 1820. Carry the 2, 3, 4, 5. So this is 0.501. And we have to continue this. Time for the 4 kids, 5 kids, 6 kids, etc. This is how we would do it by hand. It's a little bit tedious. Let's figure out how we can do it using StatCrunch or Excel. It's possible to do this calculation in StatCrunch. I'm not a big fan because it doesn't tell you very much of why this calculation works. But I'll show it to you anyways. So here I've opened up a window with just plain StatCrunch with nothing in it. I'm going to type in these values. The problem here is I need to type them in as whole numbers, not as probabilities. So that's 233, 274, etc. 98, 29, and type in the values. The routine in StatCrunch can calculate the weighted average. In other words, this says that 233 people had 1 kid, 274 had 2 kids. This is like pretending we have exactly 1,000 women. So if we go Stat, Summary Stats, and choose Grouped or Binned Data, these are like bins. The bins are in variable 2. Those were the number. Those were the values. And the counts were in variable 1. 233 women. I actually had showed you the Excel one. If we scroll down, the only thing we're interested really is the mean. So I'll click on mean, compute, 3.057, exactly the same as we got in Excel. So now let's go back to the problem. 3.057, 1 decimal place, 057 rounds to 0.1. Check our answer. Good job. That's the end of the problem.